Okay, guys, so I am going to run through the notes that I did with fifth period already. So this is just the first part of Unit 9, which is solving trigonometric equations. I know I need a haircut, pandemic times. I'm gonna try doing this on Zoom. I haven't done it on Zoom before. I usually use the Explain Everything. So we're gonna try this, and I'm gonna try another program later, and you guys can tell me which one you like the best. So what I want you to do while I am writing is get a piece of paper and like take notes as if you were in class with me. And that way I think it'll be, I don't know, I think it'll work out better, and that way you'll have something to go back and look at later. Okay, so our central question is, how do I use inverse trig to solve trigonometric equations? Such a good question. So let's start with the directions. When you are solving trig equations, what do you need to do? There are literally two steps. Number one, we are going to use our good friend algebra to isolate a trig function. And if we can, we want to get it down to just one trig function when we have an equation. If there's more than one trig function, let's get it down to just one on one side. And this will make sense later as we do a couple of examples. And then using that trig function, we're going to find all possible solutions between 0 to 2 pi. So we know that trigonometric functions go on forever and ever and ever and ever and ever. We are going to limit our solutions for the time being right now between 0 and 2 pi. I say that because there's gonna be some exceptions later on, but for right now, let's just take between 0 and 2 pi. So just some vocabulary. When you see f of x, you say that, I shouldn't write equals, you say that f of x, right? When we see, and we've done this before, we see a little -1 thing right there. What that means is f inverse of x, or you could also say the inverse function of x. And the same goes if we have a trigonometric function like that. That's going to be the inverse sine of x, or the sine inverse of x. You can say it really either way. Here's the inverse cosine of x. Here's the inverse tangent of x. So I just want to make sure that you're saying that right. So when we're talking about stuff in Zoom meetings and such, you know what we're talking about. Okay, let's skip to some examples, and as always, y'all feel free to pause this if you need to spend some time writing this stuff out, because I am just going to keep rolling and get this done so this video isn't like 30 minutes long. So example number 1, let's just do something really easy. So let's just solve for x. So 2 sine of x minus 1 equals 0. That is our problem. So if we look back up here, step 1, we want to use the algebra to isolate a trig function. So what is the trig function we are going to be isolating here? Hey guys, there's a trig function right there. Let's get sine of x by itself. Warning, do not get x by itself. You can't do that. Sine of x is all one term. You can't pop out just x by itself. So don't do that. It's just the sine of x that we can get by itself. So let's do that. I'm going to go step by step. I'm going to add 1 to both sides, like so. So 2 times the sine of x is equal to 1. Then I'm going to, let me color code this. I want it to look nice. Then I'm going to divide both sides by 2. So then we have the sine of x equals 1/2. Okay, so we've got our trigonometric function isolated. So if we think about the unit circle, let's draw just a little fun unit circle. right there. That looks great. Let's move right there. So when the sine is 1/2, the sine is our y value, right? And I know it's been 3 weeks since we've talked about this stuff. Get out that unit circle, put it under your pillow while you sleep, so that your brain like soaks up all of that good trigonometry. So sine is the y value. Sorry, that was an email. So where is the y value equal to 1/2? That happens at 2 places. Remember, we're starting here at 0, and we're looking for all of the solutions between 0 all the way back to 2 pi. So just one pass through the circle. So that happens right here. Let me draw that a little bit better. The y value at that point is 1/2. So I'm going to write the sine of x equals 1/2 right there. And that angle right there, anybody know what that angle is? Anybody? I'm just going to guess that you are saying to me, Miss Ray, that's pi over 6, and you would be correct. And then we also have a positive 1/2 right back over here. Does anybody remember what that angle is? Again, I'm just going to presume that somebody somewhere is yelling, Miss Ray, that's 5 pi over 6, which is exactly correct. Man, this remote learning stuff, y'all. It's not my favorite, but that's fine. That's fine. Okay, so we have 2 possibilities where we have the sine or the y value on the unit circle equal to positive 1/2. Y'all, the problem originally asked me to solve, which means my answer is going to be, that's right, in a solution set. So let's put our fancy squiggles there. Pi over 6 was the first place, and then 5 pi over 6 was the second place, and end that with a squiggle. So just to make sure you understand what the heck I'm talking about, what we have just found, the solution to this is the x, right? So we are looking for the angle x. The sine of that angle is equal to 1/2. So that's what these answers represent, all right? That's what we're trying to find, the angles where the sine is equal to 1/2. So that's basically going backwards, right? That's the inverse sine. So I guess a way that you could write that, if you wanted to get super official, you could say the inverse sine of 1/2 is the angle, so pi over 6, 5 pi over 6. The inverse sine of 1/2 is the angle where the sine is 1/2, because I'm going backwards. I switched the x's and the y's, right? So that's basically what I'm doing if you wanted to be able to write it. Okay, cool, that's that one. Let's do, how many examples do I have? I have 4 examples. That's fine, let's roll on. Let's do example number 2. Let's make it purple. So example numero 2. Please solve for x. Boop, boop. And here's our problem. Let's do 3 tangent squared of x. That's right, I put a squared in there. Don't be afraid. Equals 0. So the first thing we need to do, isolate the trigonometric function. Which trigonometric function do you see here? I see a tangent of x. So I want to get that by itself. Eventually we're going to want to get rid of that squared right there, but we'll cross that bridge when we get to it. So let's do our fun little algebra. So we're going to add 1 to both sides. So we have 3 tangent squared of x equals 1. Excuse me, pardon me. Then let's divide both sides by 3. I'm sorry, you have to look at the top of my head while I do this. Can you even see me? I don't even know. I don't even know if you can see me. Hopefully you can, because I'm looking rough today, y'all. So after I divide both sides by 3, I get the tangent squared of x is equal to 1/3. And then we don't want tangent squared, we just want tangent, which means what I need to do is take the square root of both sides there. And so after I do that, I get that the tangent of x is equal to, be careful, we've taken the square root, we're solving, which means that's going to be a positive or negative square root of 1/3, right? So don't forget the plus or minus there. Okay, so let's let's simplify this because I don't know a whole lot of things on the unit circle that have square root of 1/3 anywhere. And technically that's an improper way to write that because we have a square root in the denominator. So if we think about this, what this actually means is the square root of 1 over the square root of 3, right? Square root of 1 is just 1. So that's 1 over the square root of 3. How do I get the radical out of the denominator? I multiply both the top and the bottom by the square root of 3, right? Because I know that radical times radical, that gets rid of the radical. So square root of 3 times square root of 3 is in fact just 3 on the bottom there. And then on top I have 1 times rad 3. So that's just going to be rad 3. So that is a much nicer looking version of my answer. Okay, so let's think about this. Let's think about this for a second. So I am looking for a tangent of rad 3 over 3. Ooh, plus or minus, I'm looking for a tangent of plus or minus rad 3 over 3, right? So if we think about our unit circle, let me draw a little unit circle over here again. So if we think about our unit circle and we think about where in the world we have a tangent of rad 3 over 3, let's think about what tangent is equal to. Tangent is sine over cosine, right? So if we go back over here and we think about, okay, sine over cosine, let's take a look at this right here when we originally wrote it like this. If it's sine over cosine, and I know all of the things are something over 2, right? All of my ordered pairs in the unit circle, like pi over 6, is rad 3 over 2, comma 1 over 2, right? Both of those are over 2. So if I think about this in terms of sine over cosine, I can say, okay, well, if the top is 1 over 2 and the bottom is rad 3 over 2, then I'm wondering, would these 2's cancel out right here? You bet your boots they will, because watch this. If I was really doing, oh no, I erased that whole thing. If I was really doing fraction on fraction action here, this would be, let me make this not so giant. This would be 1/2 times 2 over rad 3. So yeah, you bet your boots those would cross out. And there's my 1 over rad 3 right there, right? So that means I am looking for some place where the sine is equal to 1/2 and the cosine is equal to rad 3 over 2, right? So let's think about where that happens on our circle. So sine is 1/2, cosine is rad 3 over 2. And the other thing we need to remember is we're looking for both positive and negative versions of this. So that means I can have a positive over a positive, negative over a negative, positive over a negative, and a negative over a positive. So basically any combination, right? So where's the sine 1/2 and the cosine rad 3 over 2? So that happens right here at pi over 6 rad 3 over 2, comma 1/2. That's my sine, that's my cosine. So that's pi over 6. This also happens again here at 5 pi over 6. 5 pi over 6. It also happens again here at, anybody know what that one is? Anybody? Anybody? If you're yelling at me 7 pi over 6, you are so correct. And then it also happens over here at 11 pi over 6. So all of these have a sine value of 1/2 or negative 1/2 and a cosine value of rad 3 over 2 or negative rad 3 over 2. So that means how many answers do I have? I have 4 answers. Miss Wright, are you sure you can have 4 answers? You bet your boots you can. So let us write our answers down yonder. So this is going to be pi over 6. Let me write that pi like a real pi. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Shazam-a-rama. That looks great. That looks super awesome. You will have a lot of problems with multiple answers. Don't be afraid of that. At one point in this unit, we're going to have something with, I think, like 16 answers. Super, super fun. When you get to stuff like this, y'all, please put the answers in your solution sets, put those in order from least to greatest. It just makes that a little bit easier for me. Okay, here we go. I've got 2 more examples. I'm going to keep rolling. Remember, pause this if you need to take a break and write stuff down. So let's do example number 3. Let's go ahead and solve this for x. Let's get crazy, y'all. Cotangent of x times the cosine squared of x equals 2 times the cotangent of x. What I would love for you to do is to pause this and see if you can solve this. Do it in pencil, but I would love for you to pause, see if you can solve this, and then come back and check. I'm gonna act like I'm pausing for a second. Okay, I'm back. Hopefully you like paused it and worked it and then came back. So here we go. What I am going to do is I'm actually going to move this guy over back here on the other side. And the reason I'm going to do, well, you'll see the reason I'm going to do that. I'm going to show you here in a second. So I'm going to change this to the cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. Now what I see is that both of them have cotangent of x. Each term has cotangent of x in it. Anytime you see that, y'all, you should start, especially after the last unit on trig identities, you should start to see, oh my gosh, anytime 2 items in the same expression have the same term, factor that out. Get it out of there. Just factor. Go. Factor. Boom. Done. So let's do that real quick. So I'm going to say cotangent of x times cosine squared of x, and then minus cotangent times what would give me 2 cotangent, or minus 2 cotangent, minus 2. So all that equals 0. Y'all, this is just like a quadratic, right? I've got cotangent of x times cosine squared of x minus 2 equals 0. If this times this equals 0, that means that one of those things must equal 0. That's the only way it works, right? So let's just go down here and just like bust it out and say, so the cotangent of x equals 0, or cosine squared x minus 2 equals 0, right? And then let's just solve this, right? So think about our unit circle. Where is the cotangent of x equal to 0? So cotangent of x is cosine over sine, right? So for cotangent to be equal to 0, cosine over sine, that means that sine can be equal to 0, cosine has to be equal to 0, because if sine was equal to 0, it would be undefined. We can't have that. So I'm thinking of places where cosine is equal to 0. Let's draw our little unit circle over here. Man, this iPad is great. Make it, boop. Okay, so cosine is my x value. Where is cosine equal to 0? That is going to be right up here. That is pi over 2. And then it's also going to be right down here, which is 3 pi over 2. So I can go over here and I can say, booyah, x equals pi over 2 and 3 pi over 2, right? Then let's go over here to this one. We want to get the cosine squared x by itself. So I'm going to add 2 on both sides, and then I need to, let me get a different color here so y'all can see what I'm doing. I need to take the square root of both sides like so. So I've got the cosine of x is equal to the square root of 2. Sorry, oh my golly, I've already forgotten. Boop. Plus or minus positive or negative square root of 2. Y'all, I have a problem here. This is a problem. If you type in the square root of 2 on your calculator, you'll see that it's like 1.41, blah, 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 1.414 something. This is a problem, because if I think about just the graph of the cosine, looks like this kind of. What is the tippy top? Oh my gosh, let's pretend like we're trying to draw a straight line. What is the tippy top of a cosine graph? It never goes above what? 1, right? What is the very, very, very bottom of a cosine graph. It never ever goes below -1, right? So are there any angles, any value for x that I could plug in that is going to get me plus or minus the square root of 2? No, nothing, actually, because the square root of 2, y'all, is going to be like down here and up here. That doesn't work. So for this one, there's actually no solution for my x. So my only answer will be pi over 2 and 3 pi over 2. I can't even, like, that doesn't even work. I'm not going to X it out, but I'm going to write no solution at the bottom of it, right? Now, I want to go back up to the top of this because many of y'all probably saw this at the top and we're just thinking to yourself, oh my gosh, this is so easy. Let me just divide both sides by cotangent, and then that'll cross off and I have cosine squared of x equals 2, right? We can't do that. I'm gonna delete all that. We can't do it. It's no good. Delete, 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 delete. We can't do that. In fact, I need to write us a little note up here in red. I'm gonna scoot my unit circle down a little bit. Here's my note. It starts with bold letters. Never. What do you never want us to do, Miss Ray? Oh, I'm about to tell you. Never, ever, ever divide by a function to cancel it out. So when you are solving trig identities or trig equations with trigonometric functions, never, ever, ever, can y'all see that? Divide a function to cancel it out. Because what you're going to do is you're going to cancel out possible solutions. Because you see down here, we ended up with 2 possible solutions, pi over 2 and 3 pi over 2. If we had divided and canceled out cotangent, we wouldn't have gotten those answers. And all I would have been left with was no solution, which is incorrect, right? So never, ever, 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 when you were simplifying and isolating a function by itself, never divide by a function that would end up canceling it out. Don't do it. Never do it. Cool. Y'all, I have one more example. Hopefully I'm not going too fast. I know I probably am, but I also know that you have the power of the pause button. So you can stop it where you want to and catch up. So I've got one more for you. This one's a good one. So we're going to solve for x. Boop, boop. So the sine of 2x, that's right, it's a double angle all the way across the sky, equals rad 3 over 2. So the sine of 2x equals rad 3 over 2. Now, since we just finished with the trig identities unit, I imagine that a lot of y'all see that sine of 2x and are running off to your identity sheet and are trying to find out a bunch of things that double angles work with. Good, that's a great instinct. However, it's a lot easier than that. You don't even have to include those identities. So, excuse me, pardon me. Let's do this. What I'm going to say, remember what I wrote up at up at top. I'm going to say that 2x is equal to the inverse sine of rad 3 over 2. I'm going to write that 3 again. Rad 3 over 2. So what that means, this 2x represents angles where the sine is equal to rad 3 over 2, okay? Where x and y have switched. So this represents angles where the sine is equal to rad 3 over 2. That's what that fun little inverse guy means right there, okay? So what we want to do, follow me here for just a second. We want to find all solutions for 2 rotations of the unit circle. So from 0 to 4 pi. And you're probably thinking to yourself, Miss Ray just told me that we're only going from 0 to 4 pi. What the what? Here's the thing. When we get x by itself, we're going to be dividing it by 2. So we're going to need to find everything for 2 rotations, because then we're going to divide it in half, and it's just going to get me back to 1 rotation. If you have no idea what I'm talking about, follow me here. Let's think about this. So all things between 0 and 4 pi. So let's draw our unit circle over here. You know, they are just getting there. That's fine. Okay. So where is sine equal to rad 3 over 2? Only positive rad 3 over 2, right? Not positive or negative, just positive rad 3 over 2. So there are 2 spots. Let's zoom in on this little unit circle right here. There are 2 spots. It's going to be right here. That is, anybody? Anybody? I'm going to pretend like somebody in the back is saying pi over 3. Good job. Good job. That is correct. Good job. And then this also happens right here. Anybody? Great. 2 pi over 3. Good job. Way to get that right. Okay. So that's between 0 and 2 pi, because I'm not looking for the negatives down here, so I don't need to include those. So now we want to go around again. So let's think about if I'm going all the way around, and I'm doing that again. Basically, does anybody remember what these are called? I'm looking for coterminal angles, right? I'm looking for another angle that ends up right here, but that's a coterminal angle, right? So to find those, I don't know if y'all remember, we're going to do pi over 3 plus 2 pi, right? Which gets me, so 2 pi is 6 pi over 3, so that'll be 7 pi over 3. And then I also want a coterminal angle for 2 pi over 3 plus 2 pi. So that is equal to 8 pi over 3. So those are my possible solutions between 0 and 4 pi, 2 rotations, right? So let's get back over here. And I'm going to say, all right, so 2x is equal to pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3. Everybody with me? You see how I got those? So those are the angles where the sine value is rad 3 over 2, and I did it for 2 rotations. Here's why I did it for 2 rotations. I don't want 2x, I want just x, right? I want just x. So how do I get that 2 out of there? I divide by 2. Let's make it a little bit easier. I'm going to say, instead of dividing by 2, I'm going to say I'm going to multiply by 1/2. I'm going to multiply all of these guys times 1/2, right? So when we do that, I get x is equal to pi over 3 times 1/2 is pi over 6. 2 pi over 3 times 1/2 is, what's half of 2 pi over 3? Just 1 pi over 3. 7 pi over 3 times 1/2 is going to be 7 pi over 6. And then 8 pi over 3, so half of 8 pi over 3, that's going to be 4 pi over 3. Y'all, do you notice something about those 4 angles? Are they all between 0 and 2 pi? Yes, yes, they are, because we found all of the ones between 0 and 4 pi and then divided by 2. So these are the ones between 0 and 2 pi. Blam. Blam. God, I love math so much. I miss you guys. I love math a lot. I wish that we were all in the same room to talk about this. Okay, so the last stop is just to me write those in a fancy solution set. 7 pi over 6 and 4 pi over 3. All right, donezo. Okay, y'all, I am done. I'm gonna draw, of course, a penguin here on the bottom, just to make things a little fancy. If you need help at all, please send me an email, let me know, or come to one of my office hours. I think I said for this week, I'll be in front of a computer from 2 to 3 every day, p.m. So send me an email, I'll be in front of a computer. And if it's something that we need to like arrange a quick Zoom meeting, then let's do it. All right, rock and roll. Peace, love, math. I hope we've had fun.